I'm Srikar from Aerobi section. The topic for data structure is application of linked list, and my roll number is 20951 E21B3. When we say about application of linked list, so we will get information. Application of linked list. When we talk about that, circle linked list and double linked list and multi linked list. Application of linked list. Linked lists are frequently used to implement other data structures such as trees, graphs, and heaps. Linked lists are useful for creating dynamic stacks and queues, which can grow or shrink at runtime. Linked lists can be used to store a process of polynomials. A polynomial is an algebraic expression in which powers of one or more variables appear in a summations. The coefficient and power of different terms of a polynomial are stored as nodes of a linked list. The linked pointer points the next term in the polynomial. Figure shown, for example, represent a polynomial consisting of three terms. When we say a polynomial 3x to the power of 5 minus 4x squared plus 5, here for linked list, 3 and 3 is a variable and 5x to the power of 5 is been denoted. And when we see a 4x cube, 4 minus 4 and square is been denoted. When we say here 5 and 0, where no, we indicate 0 because there is no term given. Application of linked list. We can also use two-dimensional array to store a polynomial. Figure shows such a representation. However, array is not suitable when the polynomial is sapress. Polynomial 3x to the power of 5 minus 4x squared plus 5. 3x to the power of 5. When we say we are find there with the after 5 4 values have been missing. When we say about x to the power of 5, we will get 1 2 3 4 5. So in place of missing terms, we have to keep 0 in that box. When we say 4x to the power of 2 minus 4x to the power of 2 x squared, 4 and 2, where no more terms. So when we say about 5, and when we say about 0, we kept last 0 because the term, there is no term after 5, so we kept 0. When sapler of polynomial is 9x to the power of 50 minus x 3x plus 2, linked list 950, and when we continuous minus 3 1 2 0. Cursor implementation of linked list. Linked lists are normally implemented by using pointers. This representation is referred to as reference-based implementation. Linked lists are normally implemented by using pointers. This representation is referred to as reference-based implementation. Some languages such as Visual Basic or Fortran do not support explicit or implicit pointers. In such situations, linked list can be implemented using arrays. This representation is called cursor implementation. In cursor implementation, two arrays are used to store information fields, link pointers. Figure shows an example of cursor implementation where index 1 where data of array 1 2 3 4 5 6 7 8 list nodes D E F A G C B H, pointer array index 1 2 3 4 5 6 7 8. Here link pointers are 2 3 5 7 8 1 6 and below none. A is denoted, B is denoted, C D E F G H. Circular linked list. In a regular linked list, we cannot go back to any other preceding nodes. A circular linked list overcomes the limitations. In a circular linked list, the pointer in the tall nodes points the front nodes. The list has no front or tail nodes. To make entry into the circular linked list, a reference node is used, which is identified by the external pointer. This pointer is referred to the head pointers. Circular linked list. Figure shown an example of circular linked list can be used to recreate processes which are executed in cycle. An operating system might use it around robin scheduling for tasks. as regular list can be perform basic operational on a circular linked list. Here, circular linked list figure shows an example of a circular list. It can be used to represent processes which are executed in cycle. An operating system might use it around robin scheduling the task. As a regular list can be perform basic operations on a circular linked list. A tends to B, B tends to C tends to D, E tends to E tends to F. Advantages and disadvantages of circular linked list. When we talk about advantages and disadvantages of circular linked list have some advantages over the regular linked list. Any node can be designated at the first node. Each node is accessible from other node. A circular linked list is a particularly suitable for process strings. Limitations is that unless starting node is identified, transfers of the circular list might go into the infinite loop. When we see about advantages, any node can be designed as the first node. Each node is accessible from any other node. A circular linked list is particularly suited to process strings. Limitations is that unless starting node is identified, transfers a circular list might go into the infinite loops. Basic operational on double linked list. Basic operations include intersection, deletion, transversal, sorting, and search. Unlike is a regular list, we can transverse in forward and backward direction. In other words, we can perform the directional transverses. Insertion and deletion can be performed by adjusting left or right pointers. These operations also requires adjustment of left or right pointers. Basic operations of insertion, deletion, transversal, sorting, and searching. Unlike a regular list, we can transverse in forward and backward direction. In other words, we can perform bidirectional transversals. Insertion and deletion can be performed by adjusting left and right pointers. These operations also require adjustment or left or right like pointers. Basic operation includes insertion, deletion, transversal, sorting, and searching. Unlike a regular list, we can transverse in forward and backward direction. In other words, we can perform directional transverses. Insertion and deletion can be performed by adjusting left or right link pointers. This operational also requires adjustment of left and right link pointers. Basic operations or double linked list. Insertion a node into a double linked list. Node can be inserted at front, middle, or tail. Procedure for front and tail is similarly to one for the regular linked list. Similarly to insert in middle, we use a pair of temporal pointers. Figure illustrate the insertion for middle or nodes. A to B, B to C, C to D, D to C, C to B, B to A to B, B is pointer 1, C to D pointer 2. So when we say A to D and C to D, A to D and D to Z, Z to C, C to D, D to C, C to Z, Z to D, D to A. Insertion a node into a double linked list. Advantages and disadvantages of double linked list. Main advantages are it allows a directional transfers. Insertion and deletion are fast. Sorting list can be printed in ascending or descending order. Major drawbacks are additional storage space is required for the link pointers. Address of preceding and succeeding nodes need to be closely tracked. Circularly double linked list is a variant of double linked list. In this case, next link pointers in the tail node contains pointers to the first element. Previous link pointers in the first node pointers to the tail node. Since no first node are defined, we can choose an arbitrary node as the head node. A circular double linked list has the advantages of circular and double linked list. Its main disadvantages of link pointers need to be closely monitored, otherwise transfers can be lead to the infinite loop. Circular double linked list A to B, B to C, C to D. Multi-list. We can combine a set or related like structures into the integrated list multi-list. To build the multi-list, we need to additional link node. Thus, multi-list contain nodes that contain subject data, link pointer, subject, nodes that can subject data and link pointers to the students. Thank you.